Welcome to this overview of the Hobby Capacity Manual 7th edition highlights, just to go through the main points and the changes chapter by chapter. Not much in depth, but just to give you a feel for what happened in this new edition. As you know, Hobby Capacity Manual is owned by the Transportation Research Board, and the Hobby Capacity software is implemented by the University of Florida McTrans Center. And so this is the 7th edition of the manual that's just been released, and the software has implemented most of the changes already. My name is Bill Sampson. I was with McTrans Center for over 30 years, responsible for development, technical support, and training for the Hobby Capacity software. I retired a couple of years ago, and you see my contact information there now. When we have a webinar, we handle things through the chat, but this is just going to be a brief recording. And I've sort of highlighted the things that draw your attention. The connected automated vehicles are modeled at some level by essentially increasing the capacity as a function of the penetration rate of the CAVs within the general traffic. The two-lane highway chapter has been completely redone and replaced. There's a new chapter on network systems where it's really modeling the interaction between freeways and arterials, where queues can go back and forth to one or the other at an interchange. And one thing that's not noted on here is the pedestrian analysis can now model different types of crossing treatments. So we'll focus on the new procedures, and I'm just going to hit the highlights. I'm going to try to stay out of training course mode and just show you what's happening between the 6th edition and 7th edition. And I've got a couple of little screenshots to show you how it's implemented in the Hobby Capacity software. The organization is pretty much the same, but things changed a little bit. Lots of research projects. I'll show you a slide on the new research. And again, these are the big points: connected automated vehicles in most applications as a function of their penetration rate. Two-lane highways completely redone, looking much more closely at geometric conditions, which makes sense. And now the level of service measure is follower density instead of average travel speed and percent time spent following. Pedestrian level service and delay is now you can now look at different crossing treatments to model those explicitly. And the network analysis is that interaction between freeways and arterials, where an on-ramp could be going to a congested freeway and back up to the signal, or an off-ramp could be going to a congested signal and back up onto the freeway. It's really kind of modeling those two things in the manual. And that's, I guess, what this is saying. Freeway signals and roundabouts all have places for the capacity and for signalized intersections, the saturation flow rate, to be increased as the penetration rate of CAVs increases. The vertical and horizontal alignment is dealt with in great detail in this new procedure for two-lane highways, with slope coefficients, power coefficients, to come up with a way to help that model how the two-lane highway is working, to get follower percentages and turn that into follower density, so that it's a density-driven level of service like all other uninterrupted flow procedures. The crossing treatments, I believe there are 13 or 14 different crossing treatments that can make a difference in the pedestrian delay and level of service. And the network systems, the interaction of queuing primarily at an interchange. So just to briefly say, this is the history of the Hobby Capacity Manual. We had a 6th edition, actually major changes in 2010 edition. 6th edition came out in 2016, and this new version came out earlier this year with some expanded methods and 38 chapters. That chapter 38 is the network systems chapter. And just to highlight, this is a a slide I use in my training course to show you the changes since 2010. So these are showing the changes that moved up to 2010 between the 2000 and 2010 manual. These are showing research going up to the 6th edition. And I usually go through these one by one, but in this brief highlight, I'm just going to draw your attention to the National Cooperative Highway Research Program projects for the 2-lane highway chapter, for the network systems chapter, and for the implementation of the pedestrian crossing treatment procedures. And a pooled fund study generated the adjustment factors for CAV penetration in almost every part of the procedures. It's an ebook now, the Highway Capacity Manual, 7th edition, but I believe it's supposed to be printed just about any time now. And the volume 1 is an overview. Volume 2 is uninterrupted flow, freeways and highways. Volume 3 is interrupted flow, intersections and arterials and interchanges. And then appendices and supplements are in volume 4, and that one's posted online. So just to kind of bounce you through what each of these volumes includes, you have a user's guide as chapter 1 in volume 1. And I always point people to chapter 8 if you're trying to get information to tell the general public what the HCM actually is. And then you see the freeways and highways, volume 2, and I've underlined 2-lane highways, which changed significantly. One thing I'll mention about freeway facilities is that in anticipation of the network analysis, it is now modeling the freeway lane by lane. And in the interrupted flow, you don't see any underlines here, but actually 2-way stop control has that change for the different crossing treatments, and others have the CAV interaction in them. Most of them do. I'm not sure about ramp. I don't think ramp terminals and alternative intersections do yet. And then in the supplements, it's probably not appropriate to call chapter 38 a supplement. That's where it got put, and that's the network systems for interchanges, freeways and arterials interaction. And as you all probably know, the capacity manual is run by the Transportation Research Board, and the Federal Highway Administration and the National Cooperative Highway Research Program have funded research since prior to the 1985 manual. And the Highway Capacity and Quality of Service Committee reviews every step of those new improvements or changes or additions, as does the NCHRP panel. In the subcommittees, you got 200 or 300 experts looking at all of this very closely before it gets approved, which makes this most research-built, peer-reviewed, most defendable procedure out there. Highway capacity software maintained at the University of Florida is faithful. Whatever the manual says, it's the tool that implements it. The McTrans folks stay very close to the committee, always there, knowing any slight change that is made formally approved, and moves it right into the software right away. Brief history of the HCS, and you see down toward the bottom, HCS 7 was implementing the 6th edition of the manual in 2016, HCS 2022 implementing the 7th edition. So this is what the new software looks like. It's architecture and main menu screen have changed quite a bit actually, and just to make it more maybe available to each of these different modules that pretty much parallel the chapter interrupted flow, uninterrupted flow. So let me just go through each chapter, and several of these are going to be minor changes, if any changes at all. It'll go kind of quickly. Basic freeway segments. The idea of increasing capacity as the penetration rate, or the percentage, if you will, connected automated vehicles in the traffic stream. And the implementation of software kind of shows you put in this percentage here, and it adjusts the capacity. Adding 60% would add 13% to the capacity in this particular example. For weaving, same thing. The proportion of CAVs on the weaving segment and the increase in capacity as another capacity adjustment factor. And merge and diverge, same thing. A little bit different each time on how it looks like on the screen, but you see that same 60% gives you the 13% increase. So for the freeway segments, the implementation of CAV percentages to improve capacity are using the same process. Now, merge and diverge does have some interaction with network analysis. We're talking about the interchange with the arterial. Freeway facilities, again, if it's done in a segment, it's done in the freeway facility. For the 60% CAV generating a 13% capacity adjustment increase, and it's done segment by segment. And typically the segments with on-ramps and off-ramps might change the percent CAVs segment by segment, so the capacity increase would change as well. Multi-lane highways, really no changes in the 7th edition. Two-lane highways pretty much changed completely. Follower density is the service measure to determine level of service. You have two different categories of speed above and below 50 miles per hour, which makes sense. And lots of details on vertical and horizontal alignment, because in a two-lane highway, you can see how that would affect traffic and the flow of traffic in different ways. They generate, this procedure generates the slope and power coefficients for speed, and ultimately makes its way into follower density, followers, number of followers and follower density. In the HCS, they combined highways module so that you choose between the two-lane highways and multi-lane highways, and updated the interface on two-lane highways. So when you're looking at multiple segments, which you did not do before, you can get a full view in the software. Two-way stop control, as again, I've mentioned this, is 15 different implementations. It's a little bit harder to read in here, but you see these different crossing configurations, and I'll just read them to you. Pedestal mounted flashing beacon, overhead sign, overhead flashing beacon that's either push button or passive, in roadway warning lights, median refuge island, pedestrian crossing flags, and street pedestrian crossing signs, rectangular rapid flashing beacon, RRFB, school crossing guard with an RRFB, the hybrid beacon, which is sometimes called the hawk signal, mid-block crossing signals, and half signals. So lots of things there, lots of different treatments that might affect pedestrian delay and level of service. For always stop, really no change in the 6th edition and no change in the 7th edition. Roundabouts does also implement the increase in capacity as a function of the percent CAVs. It's not the same algorithm and interrupted flow. And you see in this case, 40% CAVs generates a 14% increase in capacity at a roundabout. For signalized intersections, again, the interaction of CAVs or the penetration rate increases the base saturation flow rate. And you may or may not know the base saturation flow rate gets modeled to generate an adjusted saturation flow rate, and then that gets converted to capacity, knowing the green to cycle ratio and the flow rate. Pedestrian delay, those 15 crossing treatments may indeed change the pedestrian delay at a signal as well. And you see the 80% CAV generates a 21% saturation flow rate base increase. That has not yet been implemented in the software, and the pedestrian delay at signal has not yet being those crossing treatments in the software either. Urban streets, and you see that the penetration rate increases base saturation flow rate really because of signal as part of the urban street. So it's being done at the signalized intersection as well as pedestrian delay. So those percentages look the same at the bottom because it's really done to the signal, and the signal is part of the urban street. Interchanges and alternative intersections. I don't believe this is integrated into the software yet, but there are signals. There are signals at the crossover of the DDI. There are signals at the crossover of the displaced left turn. There are signals at the main intersection and the U-turns potentially for R-cut. And this is an MET down here, potentially has signal here, and even the crossovers. So where signals are, the CAV can make a change to the saturation flow rates. The network system, I believe this is going to be very, very important, where the Q spill back from a freeway to a signal on an arterial, or from an arterial signal back up onto the freeway. We know that happens in many places, and now this will be modeled explicitly. So when you've got a green light and you can't go because of the Q, it generates some additional loss time. And when you get the Q up onto the freeway, then the freeway is modeled lane by lane in order to the outermost lane will be affected more, and the outside lane, the leftmost lane affected less. And so it really had to be modeled lane by lane with spillback checks to the ramp terminal, whether it's stop control, roundabout, or signal. Simulation. The simulation up here in the right-hand corner, which has always been the way of modeling the arterial freeway interaction, is now going to be supplemented. The procedures will model it, and then you'll be able to animate it, maybe compare the two, just like you do other procedures that the HCM models. The two main things that still are left over are Q spillover, where the left turn, the Q is longer than the left turn lane, and we use simulation to model the effects on the adjacent through lane because the manual doesn't do that. And a free right turn, we have an exclusive right turn lane at a signal that's not controlled by the signal. This affects the approach and intersection delay. And what the manual does not do is compute this delay as this traffic enters the cross street with a stop or yield sign. So you simulate this and adjust it in the software. Transmodeler, you may know, is integrated with ACS now for signals in streets and stop control and freeways. And I think roundabout is not yet implemented just yet. So Transmodeler is a click away to get you animation and to get those fill those gaps in the capacity manual with Q spillover and free right turns. So on June 8th, I'm going to do a 90-minute version of what I've just done, expanding the look at the CAVs a little bit, expanding the look at two-lane highways and network systems quite a bit, and looking at a little bit more detail on the pedestrian analysis crossing treatments. So that's coming up on June 8th, and trying to show what's in the software, how it was implemented, and maybe what's coming. And then I've also developed a course, I've done it once, where it's a 3-day training course covering all procedures, all chapters, whether they changed or not, but it has been updated to include all the minor changes throughout the chapters and these major changes that I've mentioned several times here. It's a 3-day, 12-hour course, 3 4-hour days. But it's 3 5-hour days if you really want hands-on workshops where you work problems by hand, or you code them into the software as part of the class. So both flavors are out there, and certainly willing and anxious to present those to whomever needs it. So thank you for taking a look at these changes. Please come on June 8th if you want a little more details for two-lane highways and network analysis primarily. There's my contact information, and please let me know if I can help in any way down the road. Thank you very much.